Ladies and gentlemen, and friends and aficionados of Algebra 2, this is the Algebra 2 2022-23 first semester test review. I'm not going to go over all of these 30 problems, but 9 of those most commonly missed by our most advanced students. And I'm going to go straight over here to problem number 6, which is a polynomial subtraction problem. And basically what you're trying to do is simplify this subtraction, find the difference. And so basically you can make use of this situation, the fact that you have multiple choice answers, and so you can kind of distinguish between these. So I'm going to go ahead and try to tackle it that way. So we're going to concentrate on these cubed expressions first, 12x cubed, and then we have minus negative 18x cubed. So if we have 12x cubed and we have minus negative 18x cubed, so that's going to end up being plus 18x cubed, which means that our x cubed expression is going to be 30x cubed. And what that does, it enables us to eliminate answer choices B and C. And now to distinguish between answer choices A and D, what we're doing is in the first expression we have the 19, and then we're going to go ahead and we are going to subtract 3. So we have 19 minus 3, and that's going to be 16. So the constant component is going to be 16, which obviously eliminates answer choice A. We get answer choice D. And then if you go ahead and work this out to the final conclusion, if you take just to further confirm, we're going to have negative 8x squared, and we're going to subtract out 6x squared, which is going to be give us minus 14, negative 14x squared. So that confirms that term. And now the x terms, we have 5x in the first expression, and we're going to have minus negative 9x, so that's going to be plus 9x. That's going to give us plus 14x. So further confirming D is our correct answer. Now, one thing I'm not going to mention is that I'm going to skip most of these, and in skipping most of these, that means that the students got those mostly right, which is really a great thing. Now, in 10, we have this problem. We have an area of a rectangle. It's a very simple problem, but written out in a way that's not going to be as familiar to some. And so what we have is we have to know the situation that the area of a rectangle is equal to length times width. And so that means if we take the length, which is fixed here, and we multiply it by which one of these that I've now circled here in the answer choices times 3x minus 1 is going to equal the area here. And so I'm going to go ahead and one very good student got answer choice C, which happens not to be the right answer. We can test out answer choice C by taking it, and what I'm going to do is I'm just going to leave this like a box here. I'm going to pretend, okay, our length is going to be 3x minus 1, so I'm going to put 3x minus 1, and let's try answer choice C. And we do that, we're going to put x minus 1 here and multiply these together, so we get 3x squared minus x minus 4x, 3x times negative 1, and then plus 1. So for this all together, we're going to get 3x cubed, or x squared rather, 3x squared, and negative x plus negative 4x will be negative 5x, and plus 1, which is not our area here, so this is not going to be a correct width. So let's go ahead and try what I believe the right answer is going to be. I think it's going to be B. So trying B, let's try B. So we try B, we're going to have x plus 2, so we get 3x squared minus x plus 6x and minus 2. So in putting all these together, we're going to get 3x squared plus 5x minus 2, which is our area here. So B is our correct answer. It's number 10. Okay, next, we're going to go all the way to 17. And again, going past all these that students pretty easily mastered. Okay, 17 is a conceptual problem. Which of the following is not a possibility as a result of solving an absolute value equation? And one thing we did on this is we showed that there are 3 different possibilities if you have an absolute value equation. So if you have an xy, and you'll have typically one side of the equation will be some kind of a horizontal line, and the other side will be the absolute value function. So if we have the absolute value graph like this, I'm drawing this and this v. The possibilities are that we have 0 solutions where the line and the v do not intersect at all. We have 1 solution. So no solutions, 1 solution, or 2 solutions. So the impossibility we have here of all the answer choices is 3 solutions. So 3 solutions is our correct answer. Now I'm gonna show a graph of a type of problem later on in this review too, so just hang on for that. Okay, next one we're going to look here is problem 20. Problem 20 and 21 are evaluating a graph. For the graph of the function fx shown below, over which interval does the function fx have a negative rate of average rate of change? And here I'm looking at the test of one of my more advanced students. Yeah, I'm just looking at the paper here. Yeah, this student I'm looking at here got answer choice A to number 20, which answer choice A is -4 to 0. So if we go here at x equals -4 to x equals 0, between these 2 points exists the line connecting those 2 points is a positive sloped line, meaning that there is a positive rate of change between those 2 points. So A is not the right answer. So let's just go ahead and through the other choices from 0 to 5. Well, if we go from x equals 0 to x equals 5, I'm going to erase those. We go from x equals 0 to x equals 5. Okay, and we connect these 2 points. Again, we have a positively sloped line. So B is not our right answer. Next, answer choice C, we go from -3. So here's at -3, that's our output value, and to -1, and here at -1. And so here, answer choice C does give us a negatively sloped line connecting those 2 points, and so that should be our correct answer. The only thing we could do in addition to this to go to completion is check answer choice D. If we go from -5, so here's our input -5 to 5. Okay, again, answer choice D gives us a positively sloped line connecting the 2 points. So D is not correct. All right, C is our answer there. Next, 21. Again, this is a very commonly missed problem. Shouldn't have been, but was. For the graph of the function f of x shown below, over which interval is the function f of x increasing? Well, to find the only place we're increasing is in this interval here between about x equals 0 to x equals about 3 or 4, thereabouts, I guess. So 0 to 4 is our only correct answer. Let's see what our students got for that. Answer choice C here. Somebody chose answer choice C, which is from -3 to 0. Well, here, from x equals -3 to x equals 0, we are decreasing all over this interval from -3 to 0. Let me see what this other person did here for 21. Just looking at a couple of these tests here. Okay, we see, yeah, this other person for 21 chose answer choice D, -5 to 5. Well, -5, from -5 to 5, well, it does include that interval where the function is increasing, but also does not include the whole thing. And if you look at it, you're looking for the best answer. If you look at the graph in detail, the thing doesn't exactly increase all the way to x equals 4, almost, because it looks like it tails off at about 3 or so. But again, you're looking for the best answer, and B is by far our best answer. Next one we're going to look at here is the back page, which is going to be 27 through 30, which would be our free response problems. And we're going to rev up the Get Graphing Calculator to take a look at these. Here we have 27. Holly takes a basketball shot whose elevation versus time is given by this function, and how much time in seconds does it take for Holly's shot to reach its maximum height? And I had one student who kind of misinterpreted what is being asked in this problem, and is trying to factor out this answer. So she puts here -16 t squared, and she's trying to, and then 7, and she's trying to factor all this. Well, you're not really being asked to factor. You're asked to evaluate this function right here, which is the function of height versus elevation. So a complete misunderstanding of what's being aimed at here from the beginning. And so we can go ahead and what you're going to find for these projectile motion problems is this. And we went over enough sample problems. I thought this should have been answered, but you're looking for a projectile motion type of a situation like this, and you're trying to evaluate here at this maximum, and you're being asked to find in this general type of problem either the time it takes to reach that maximum height, or the actual maximum height that is reached. And so you have to know that point, and to find where it is, you have to be able to take a good look at it somehow to analyze it. And so it says also to the nearest tenth of a second. That's a key item. So I entered this right here previous to starting the video, and I'm just going to press enter here in the function editor, press graph, and we can see just the start and the finish. It looks like it takes a little over 3 seconds because these are by 10. So I'm going to go ahead and take the window and go from 0 to 4 seconds, and I'm going to go for a maximum height of, I don't know, it's a basketball shot. I don't know if 30 feet is enough, but I'll try 30 feet, see what we get here. Yeah, 30 feet is not quite enough, which is not a realistic. At 30 feet, you're talking about scraping the top of the high school gym. So let's go up to 50. And I'll go by 5s, increments. Yeah, there we go. So we can see, you're looking graphically to see the very apex, the maximum here. And you can from here go one of a number of different ways. One way of which is to go ahead and push trace. You press trace and you can just scroll. And if you have it set up pretty well, you can just go ahead to the, you're trying to get the time, and the x value is the time where we reach that maximum height. Well, we're still increasing. So you look at that y value at the right, and it's still increasing, increasing, increasing. Okay, now we're decreasing from there. So this is our maximum height. We see 42.996. It's going to be about 43. And we see we have 1.48, which when rounded to the nearest tenth would be 1.5. So we'll have like 1.5, comma, 43.0 rounded to the nearest tenth in height. So you're looking for this value right here. 1.5 is our answer, and we can put 1.5 anywhere here. Let's go ahead and bubble this in right. 1.5. All right. So another way to do there are other ways to do it. I'll show you another way. You can go to second trace maximum, and then it says here it says left bound. So you just scroll over to the left. Once you're to the left of the apex, you press enter, and then you scroll back to it says right bound question mark. You scroll to the right and press enter twice, and here you get our maximum. And it says maximum. It's kind of confusing because right under maximum it says x equals, but the actual value of the maximum is this y value. So 1.5 is our time, just as entered earlier. And lastly, you can take a look in the table view. If you go to the table view, you see these values here for the first 3 seconds. You're not seeing your maximum value of 43. You're kind of halfway between those. But if you go to tenths, and to get to tenths, if you go to table set, we can start at 1, and we can go by table delta. That's triangle means delta, change in table value. So we're going to have 0.1, and now we go to the table view, and what we can do is we can see which one of these on the right is the highest, and the number on the left that lines up is the correct answer, which again, for the third time, in the third way, 1.5. Next, we have what is the minimum of the function g of x equals 2 times quantity f x minus 4 squared plus 5. And I had these two students' tests I'm looking at had answers of, one had an answer of 7, one had an answer of 14. How they got those answers, that's a question mark for me. But what you have is the vertex is given by the coordinate pair h comma k. In a situation like this, h is going to be equal to 4 and k is going to be equal to 5, which means our vertex, and I'm going to just draw it out here, our vertex is going to be here at x equals 4 and y equals 5, and here it is, and we have a being positive, so we know it's going to be an upward opening parabola, something like this. So our minimum value here is going to be this thing right here, 5. So 5 equals minimum value. And again, we can just put any of these 5s here. And next I'm going to show you in a calculator, because really with calculator in hand there's really not a reason to miss this problem. So let's go ahead and take a look at putting this in the calculator. And I already did. Let me go ahead and I'll go ahead and clear this out. And go down here, activate that equal sign. So we graph, I'm going to go to a zoom 6, get to a standard window, and here we should be able to see we have a minimum value of 5 where x equals 4. We can check using the table view. And again, I still retain my table setting from the earlier setting for the problem 27, but we see the minimum value here is 5. 5 is our correct answer. Next, 29. How many solutions are there? Now, I got all kinds of different answers for this one. One of my excellent students whose test I'm looking at actually worked this out and misunderstood, didn't pay attention. The question isn't what is the solution to, it is how many. So careful reading, how many solutions are there? That is what's being asked. So again, just another admonishment, read carefully what is being asked. So let's go ahead to, I'm going to go ahead and enter this in the calculator to see what it is. Now, already we should know that our possible answers are going to be 0 for none, or 1 or 2. Those are the only possibilities we have. And let's go ahead and enter this in the calculator. What I'm going to do now is I'm going to erase this. And one reason I didn't pre-enter this, I want to review. I'm going to enter both sides, and I want to review how to enter the absolute value function. So now I have 2. I'm going to press second, catalog, and by coincidence the alphabetical order takes absolute value function to the very top of the list of the alphabet. So right there, and here's where we're going to put 2x plus 4. And then outside the absolute value bracket we put minus 3. And then, oops, I put negative 3. Let me put minus 3. That's a key thing. Minus 3. There we go. That looks better. And then for this second equation, the right side of the equation, we're going to put negative 3. And we're going to graph, see what happens. And what we see is we intersect at exactly 1 point. I'm going to go to table set here and change this from 0. I'm going to go to standard default. So if we go to table value, we can see that it's where x equals negative 2 that we get exactly the same number. So that means we have this look here is one solution. That is the answer. So we have one solution right here. And if I had somebody who got negative 2 as an answer, if you actually go ahead and solve it out, which this one very good student did, she ended up getting negative 2 as the correct answer. And negative 2 would be the solution for it, but is not the answer to the question. And so if you add 3 to both sides and so on. So anyway, that is that one. And the last one we're going to look at is answer choice 30. Yeah, not very many people got this one wrong. But what is the solution to this? Let's go ahead and work it out. So we have absolute value of x minus 3 is equal to 4. And so if we add 3 to both sides of the equation, we're going to get absolute value of x is equal to 7, which will manifests itself as x equals 7 or x equals -7. So either 7 or -7 would be a correct answer to this. I'll just put 7, or you could put -7 too. But that, ladies and gentlemen, are all the ones we're going to be looking over here. I hope this has been helpful to you. Good luck, and thanks for viewing.